Dear students, let us continue our study in this paper of forensic toxicology, and in this module we will study about the instrumental analysis of poisons part 1, and the focus will be on chromatographic techniques. If you look at the learning outcomes of this module, after studying this module you shall be able to understand the significance and the principle of chromatography. You shall be able to know and comprehend various chromatographic techniques and understand their methodology, and you shall be able to understand how these chromatographic techniques are applied for the detection of poisons in forensic science. Chromatography, if we begin with, you are already aware it is defined as a technique of separating a mixture of components into individual components through equilibrium distribution between two phases. Chromatography is a non-destructive method for determining a multi-constituent mixture of trace, minor and major constituents into its separate fraction, and that is why it becomes very important technique in forensic science. Chromatography was first of all studied and invented by Russian botanist Michael Semyonovich Twist in 1906. The chromatography has turned out to be one of the most significant analytical methods for the identification and quantification of compounds in the gaseous or liquid state. The simple principle, if we talk about the chromatography, is based on the concentration equilibrium of the components of concern between two immiscible phases. Out of these two phases, one is known as the stationary phase because it is immobilized when within a column or fixed upon a support, while the second is called as the mobile phase because this is forced through the first phase. So, this is moving and the other is stationary. The phases are selected such that the components of the sample, they have different solubilities in each phase. The differential migration of compounds leads to separation because one will be preferentially more soluble in one phase, so that will be moving faster, the other will be comparatively retarded on the other. Among all the instrumental analytical techniques, this hydrodynamic system is the one with the comprehensive application. Chromatography conquers a dominant position that all laboratories involved in molecular analysis can confirm. Chromatography is a physico-chemical method of separation of components within mixtures which can be liquids or gases in the same manner as the distillation, crystallization or the fractional extraction is done. The applications of this technique are therefore several, since many of heterogeneous mixtures are those in the solid form can be dissolved by a suitable solvent, which becomes certainly an additional component for the mixture. So, after this brief background of chromatography, let us try to understand the significance of chromatographic techniques focusing in case of poison detection. Among the immense range of techniques available for biochemical study, chromatography subjugates an honored position. Hardly any other analytical method have any such vital impression on the development of experimental chemistry and toxicology also in special reference. Application of this innovative technique to biochemical analysis were readily apparent. Chemical analysis of biological specimens is challenging because they comprise of a complex mixture of constituents, many of which react correspondingly with reagents carefully chosen to detect a specific compound. Analytical chemistry is not exclusively intricate when dealing with pure solutions, but the presence of several possibly inquisitive substances as in biological matrices creates a challenge. Chromatography resolved that challenge by offering a method to separate the components of a mixture and thus providing a pure specimen that could be measured for any of the several analytical methods which are available. At the same time, as any technology adapts to the application for which it is appropriate, chromatography has developed to come across the exceptional requirements of biochemical examination. Capillary gas chromatography modernized the analysis of drugs of abuse with the capability to resolve congeneric compounds. In the same way, the liquid chromatography has set way to the greater resolving ability of HPLC, that is high performance liquid chromatography. High resolution derivatives of electrophoresis, a technique closely allied to chromatography, have made the evolution from research tools into commercial applications. Chromatography endures to advance, and the adaptability of this analytical method appears outstandingly suited to experimental chemistry and toxicology application. So, as a forensic scientist, you should be very much familiar about these techniques and how you can do the analysis and get the results. So, let us understand what are the various different types of chromatographic techniques. And in the types of chromatographic techniques, we have the liquid chromatography, the adsorption chromatography, size exclusion chromatography, partition chromatography, supercritical fluid chromatography, abbreviated as SFC, thin layer chromatography is there, then gas chromatography is there, gas liquid chromatography or GLC is there, gas solid chromatography, that is GSC is there, and HPLC, which is most applicable, that is the high performance liquid chromatography. Then we also have HPTLC, that is high performance thin layer chromatography, then ion chromatography, and so these are the various types of chromatography techniques in which particular scenario will be used. You have to be first aware what are these, and then you can choose out of these which will be utilized for your particular case. So, let us begin with knowing more details about each of them, and first of all we have the liquid chromatography. Chromatographic separations in liquid chromatography, except size exclusion chromatograph, are the consequences of interactions developed between the functional group of solute molecules, solvent molecules, and the stationary phase. The interactions present in liquid chromatography are hydrogen bonding, van der Waals forces, and the electrostatic forces, which are the approaches of liquid chromatography. They are categorized as per the nature of these interactions. The approach of chromatography is appropriate for a particular separation. It depends upon molecular mass, polarity, and the ionic characters of a solute. Different methods of liquid chromatography have been developed for scrutinizing the range of mixtures in various kind of matrices. The method of liquid chromatography include normal phase liquid chromatography, which is NPLC, reversed phase liquid chromatography, RPLC, ion exchange liquid chromatography, which is IELC, and size exclusion chromatography, which is SCLC. Selection of a liquid chromatographic approach for a particular analysis also requires selection of a column, that is will be the stationary phase, and the solvents for the mobile phase. Whichever mode is selected for development of a particular method, it is important that certain standards for method validations are fulfilled. So, let us understand now what is meant by adsorption chromatography. The stationary phase here is a solid medium to which the species observe through the dual effect of physisorption and chemisorption. The physico-chemical partner involved here is the adsorption coefficient. It was established first and has a solid stationary phase and a liquid or a gaseous mobile phase. Each solute has its own equilibrium between adsorption onto the surface of the solid and the solubility in the solvent. The least soluble or the finest adsorbed ones will be migrating more slowly. The outcome is a parting into bands comprehending different solutes. Liquid chromatography by column comprising of silica gel or alumina is an illustration of adsorption chromatography. The solvent that is placed into the column is called as eluent, and the liquid that flows out of the end of the column is called the elute. The stationary phases have made considerable improvement since the time of Swed, who used calcium carbonate or inulin. Let us now understand what is meant by size exclusion chromatography. Size exclusion chromatography is a method by which molecules can be separated according to their size in solution, as a consequence linking indirectly to their molecular masses. And to attain this, stationary phases hold pores through which compounds are able to diffuse to a certain amount. Size exclusion chromatography is based upon the capability of the sample molecules to penetrate into highly porous beads like structures of the stationary phase. Separation occurs only as a result of the different degrees of penetration. Molecules of relatively smaller weight are decelerated in their progression in the column because they can pass into the stationary mobile phase within the pores of packing. And this method is referred to as gel filtration chromatography when the stationary phase is hydrophilic, and it is referred to as gel permeation chromatography when the stationary phase is hydrophobic. After this, let us understand what is meant by the term partition chromatography. In partition chromatography, the immobile phase is a non-volatile liquid that is apprehended as a thin coating on the surface of an inert solid. The mixture to be separated is transported by a gas or a liquid as the mobile phase. The solutes dispense itself among the moving and motionless parts, with the more solvable constituent in the mobile phase accomplish the end of the chromatography column first. The stationary phase is an immobilized liquid upon an inert or porous material which has only a mechanical role of support. Impregnation, the oldest procedure for immobilizing a liquid or on a porous material, is a technique now outdated because of the eminent possibility of washing out the column, which is called bleeding. Let us now understand another chromatographic technique, which is supercritical fluid chromatography. SFC, as it is abbreviated, it works as its tag proposes, a liquid in the supercritical state as its movable phase. This indicates to developments in the separations of thermolabile compounds and largely of compounds of high molecular weights. The instrument is theoretically a hybrid of gas chromatograph and liquid chromatograph. The instrumentation for supercritical fluid chromatography represents hybrid assemblies of gas chromatography and HPLC instrument, that is high performance liquid chromatography instrument. To assure the flow rate of the supercritical fluid by a syringe pump or reciprocal pump is used, which is maintained below the critical temperature by means of a cryostat regulated at around 0 degree centigrade. Gases above their critical pressure and temperature are in supercritical state, intermediate between that of a gas and liquid. Supercritical fluids have strong extraction properties because the solubility of compounds in fluid is close to that of the true solvent, and much lower viscosity permits it to percolate through the packed bed of sample. So, not only there is an efficient contact between the extracting fluid and the sample, but the fluid can be easily removed when it is released from the supercritical state. So, that is the advantage of this technique. After this, let us be very familiar about TLC, which is thin layer chromatography. Thin layer chromatography is an invaluable method used in chemistry, biochemistry and forensic chemistry. Being economical and sensitive, this technique that is simple to use can be automated. It has become important essentially since it is possible to carry out several separations in parallel. The principle of separation between phases of the sample components is though the migration of the constituents through the stationary phase is different. The separation is conducted on a TLC, that is the thin layer of a stationary phase, which is usually based upon silica gel, and it is deposited on the rectangular plate usually made out of glass or plastic or aluminum of a few centimeters in dimensions. To maintain the stationary phase on the support and to assure the cohesion of the particles, an inert binder like gypsum is mixed into the stationary phase during the manufacture of these plates. The constituents can be identified by simultaneously running standards with the unknown. Unknowns are kept and then the reference compounds are there, and whichever will have the same RF values that you already know how the chromatography samples and these are treated, and you will also study in subsequent modules in detail. So, once you identify which spot is matching with the reference in terms of its color with the spray agent as well as the RF value, then it will be the same particular component. Let us now understand another technique, which is gas chromatography. Gas chromatography or GC comprises the separation of a mixture of volatiles by partitioning between a solid or liquid stationary phase with a gaseous mobile phase, and this finds diverse application in toxicological analysis of alcohols, volatile poisons, drugs, plant poisons, etc. Gas chromatography, especially the gas liquid chromatography, involves a sample being vaporized and injected into the head of the chromatographic column. As you can see in this pictorial setup, the sample is then transported through the column by the stream of inert gaseous mobile phase. The column contains a liquid stationary phase which is adsorbed onto the surface of some inert solid. On passing through the column, volatile components impart differential affinities to the stationary and mobile phase, and they are separated in the fractions. So, the different fractions will be having these different components. There are two types of gas chromatographies. One is the gas liquid chromatography and the other is the gas solid chromatography. As indicated above, the mobile phase in gas liquid chromatography is a gas and the stationary phase is an immobilized liquid, either by impregnation or by bonding to an inert support, which could be rather basically the inner surface of the column. This is the technique commonly called as gas phase chromatography. The gaseous sample must be brought to its vapor state, and it was Martin and Sinch who in 1941 suggested the replacement of the liquid mobile phase by gas in order to improve the separations, and from this time arises the exact start of the expansion of analytical chromatography. In case of gas solid chromatography, as the name is very obvious, the stationary phase here is a porous solid such as graphite, silica gel or alumina, while the mobile phase is gas. The type of gas chromatography is very effective for analysis of gaseous mixtures or of compounds that have low boiling point. The parameter concerned is the adsorption coefficient. So after this, let us move to the next technique, which is HPLC. HPLC or high performance liquid chromatography constitutes a wide ranging purpose analytical technique derived from the most ancient form of preparative liquid chromatography. The contemporary technique is significantly improved in terms of selectivity, resolution through miniaturization and the use of very elaborate stationary phases. These phases comprise spherical microparticles with diameters of 2 to 5 micrometers or porous monolithic material that leads to a significant pressure drop in the column. A large pressure needs to be exerted upon the mobile phase to have the continuous flow of the liquid. And so this is a type of column chromatography of which a solvent with the chemicals of interest, they are forced through a thin column at very high pressure. So that's the name high performance or sometimes high pressure liquid chromatography also. The compounds are then separated out based on molecular size and polarity, and there are two types of high performance liquid chromatography. One is the normal phase high performance liquid chromatography and the other is the reverse phase HPLC. The most common type is the reverse phase HPLC, in which the silica inside the column is actually non-polar. The normal phase HPLC uses a polar column. HPLC can be used for both quantitative as well as qualitative information. The next technique we should be familiar is the high performance thin layer chromatography, that is HPTLC. HPTLC is an improvement of the technique where the sorbent material, for example silica gel 60, has a finer particle size and a narrower particle size distribution than the conventional TLC. HPTLC plates, they have an improved surface homogeneity and they are comparatively thinner. The resolution is enhanced and analysis times are shorter, and it is sufficient to apply nanoliters or nanograms of the sample. So this is sometimes also referred as nano TLC. After development of the chromatogram to a certain distance, the thin layer chromatography plate is removed and the mobile phase is evaporated. The track is then scanned in a densitometer with a beam of light in which is and then subjected to invisible and UV range of the spectra. Depending upon the mode of scanning, absorbance or fluorescence is then measured by diffuse reflectance. After this, let us try to be familiar about the ion chromatography. This chromatographic technique is concerned with the separation of ions, as the name suggests, and obviously with the polar compounds. Stationary phases contain ionic sites that create dipolar interaction with the analytes present in the sample. If a compound has a high charge density, it will be retained at a longer time by the stationary phase, and this exchange process is much slower when compared with those found in other types of chromatography. In this technique, the mobile phase is a buffered solution while the solid stationary phase has a surface composed of the ionic sites, and these phases allow the exchange of their mobile counter ion with ions of the same charge present in this sample, and this type of separation depends on the ionic distribution coefficient. So I am sure you are now familiar with all these different types of chromatography, and we will see in subsequent modules how they can be applied. So let us now summarize what we have learnt in this module. We have learnt about chromatographic techniques, and chromatography is a prominent separation tool that is used in all subdivisions of science and is time and again the only means of separating components from complex mixtures. We studied that the term chromatography was coined by Sweat in 1906 and the first analytical use of chromatography was described by James and Martin in 1952 for the usage of gas chromatography for the study of fatty acid mixture. We also studied the various types of chromatographic techniques and understood that how they are different, which is the stationary phase, which is the mobile phase, and how the separation of the components happen. Thank you.